memang. Ada di kelas pendidikan. Good afternoon, guys. We'll be starting the session in another 3 to 2 minutes. Okay, let's just wait for another 2 to 3 minutes. Let everyone join. We'll be starting the session. Okay. Okay, guys. I hope this is the strength. So, without any further delay, we'll be moving into this topic. Okay. So we have covered what are all the things we have covered. Let me just share my screen also. Before sharing my screen in the Q&A, Guys, do let me know what are all the things which we have covered until yesterday. We just got 2 days, right? In 2 days, what are all the things we have covered? We have covered about Python, right? Python and the basic data types. Yeah, Python basics, NumPy, Pandas, correct? And the notebook part is left over. I need to share that notebook part. So, guys, be active, okay? So, please be active. So, I'll just ask some questions, okay? So, is Pandas a one-dimensional data frame or a two-dimensional data frame? See, my question is Pandas a one-dimensional data frame or else a two-dimensional data frame? Can anyone let me know? Okay, I got one response. I got two. Okay, fine. So, what is homogeneous? What is it? In NumPy, we'll be getting this homogeneous data type, right? What is homogeneous data type? Yeah, in NumPy, we'll be having array, but what is homogeneous data type? I discussed this on 2 days. At two different scenarios, I have explained this. What is this homogeneous data type? Yeah, stores same type of data. Correct, correct. So, pandas is a two-dimensional data frame, okay? Pandas is two-dimensional and homogeneous means it shares same type of the data, okay? And also we have discussed what else we have discussed. So, which is faster, list or numpy? Sorry, list or array? Which is faster? List, list or array? Which is faster, guys? Array is faster than list, okay? Array is faster than list, okay? Fine. So mostly basic. So these things and so is list mutable or immutable? So list is the list mutable or immutable? Okay. So which kind of data type is immutable? Let's try to answer. I want answers from everyone. Okay. Correct. Tuple is immutable. Correct. So can we have duplicate elements in set? Is set ordered? Okay. Can set have immutable kind of data? Can set have immutable data? Yes. But set cannot have mutable data type. Correct. Okay, fine. So what are the other things we have discussed? Advantages of functions we have discussed, types of functions, difference between function, module, library, and package, dictionaries we have discussed, and yeah, pretty much that's it. So, oh no. So we have discussed all these things, right? And moving further, we have divided into NumPy and Pandas. In Pandas, we have seen to the data frame creation and doing the manipulation with the data, right? Correct. So today what we'll be doing is we'll be discussing statistics. Okay, statistics. What are different types of data available? Okay, what are different types of data available? We'll be discussing statistics today. So I hope everyone is here. So just a moment. Let me just share my screen. Okay, I hope my screen is visible to everyone. So, yeah, is my screen visible? So in between, if anyone feel like my voice is not clear, okay, in between, if anyone feel like my voice is not clear or else there is a disturbance from my end, so in that case, please do let me know, okay? What happened, Prabhash? What are you trying to say? This one today we'll be going to discuss about the statistics for machine learning. Okay, statistics for machine learning. So coming into statistics for machine learning. So statistics for machine learning. So coming into the statistics for machine learning, what exactly statistics is and why exactly do we require the statistics and how people came across this permutation and combinations. Permutations and combinations. Anyone heard of this term? Permutation combination. See, whatever the queries you are having in the break time only, the queries will be answered, and in between the session, if you are asking the queries, that will be answered by Tejas Sai. Okay. So, have you ever, you people heard across this permutation and combination? Permutation and combination. Anyone? No one? No one heard of it. So, fine. Permutation and combination is nothing but it's like following that number, okay, how we can do the combinations, how many combinations we can work out on the same number, or else to get a different logic, how many combinations we can work. Is there any order we need to follow, or else no order can be followed in the permutation and combination? That is about permutation and combination. Okay, try to explore the permutation and combination. We'll be mainly discussing about this Bayes theorem and also central limit theorem. Bayes theorem, central limit theorem, and followed by the types of data which we are having. The types of data, like what are the different types of data? Yeah, guys. What are the different types of data? What are the different types of data? So as of now, we all know that there is this two types of data, right? There is structured and unstructured, right? Yeah, structured and unstructured. Mostly, we all know this. The data will be mostly structured and unstructured, right? So let me just pull up my notepad. I will write the things over there. Okay. Structured and unstructured. Okay. So what is this structured and unstructured data? In structured data, what are all the things we'll be having in structured data means? So immediately we'll be getting to know that structured means which is in a tabular format, correct? Which is in a tabular format. Format in the sense like in rows and columns, correct? Rows and columns. So and in unstructured means it will be completely of images, videos. Those format of data will be under unstructured. Structured data means data which you can store in a tabular format. Okay, that will be the structured data. Okay. So now moving into the structured data. In the structured data, we'll be having in the structured data we'll be having these qualitative and quantitative data. Okay, in statistics especially, we are having quantitative and quantitative, qualitative data. Okay, what is this quantitative and qualitative data? So quantitative data means it is referring to the quantity. Okay, so quantity in the sense it is numerical. Okay, or else we can say, yeah, numerical is fine. Numerical. And coming into qualitative data means in this qualitative data we'll be having a categorical format data. Okay, categorical format of the data. So what is this numerical and categorical? Categorical means the data which is in number format. Okay, so structured data will be in structured data will be having in tabular format in rows and columns. Okay, and coming into qualitative and quantitative is numerical and qualitative is categorical. Okay, qualitative is categorical. So what is this categorical? Categorical is nothing but again in a text format. Okay, again it is in the format of text. Okay, so this is about qualitative and quantitative. But what happens is in this quantitative also we are having types. Okay, in qualitative we'll be having nominal, ordinal. Okay, and here we'll be having discrete, continuous. Okay, so quantitative means what kind of data? Numerical kind of data. In numerical kind of data we'll be having discrete and also continuous types. Okay, so what is this discrete and continuous? So discrete, anyone having any idea about discrete? See, whatever the data which we are having, it will be in the numerical format only. But in that numerical format also, we are having these types, discrete and continuous. Okay. So what is this discrete format of data? Discrete is nothing but which are countable. Okay. Mostly which are countable. In that sense, we can get an example of a number of children in a class, or its number of cars in a parking lot. Number of cars in the parking lot. Anyone can give any other example? Countable. It's like countable. Okay. Like descriptive. Uh, Anyone any examples? Okay, how many weeks in a year? Deck of cards. Number of students in class. Yeah. Okay. Fine. So hopefully everyone got to understand about discrete, right? So now continuous. What is this continuous? Continuous means we'll be having what kind of data we'll be having in the numerical kind of data, but the data will be in a certain range. Okay, within a certain range. Certain range means, so let's say I'm working on a machine learning model, and there the thing is regression means you'll be having the data and the target column will be numerical. Okay, for now just remember regression target column is numerical. Okay, so what happens is when I'm saying continuous, the data will be in a certain range. So it's like a number of students, or else the height of the students in a particular class. So it will be from ascending to descending, right? The height. So which is in a certain range. Okay, which is in a certain range. So that is one best way of describing continuous. Okay, that is one best way of describing continuous. Okay. So is it clear, guys? Yeah, measurements we can say. Yeah, books in a library. Okay, so what is this nominal and ordinal? What is nominal and ordinal, guys? What do you understand by nominal and ordinal? So quantitative is clear, right? Sorry for that. It's raining heavily. Sorry for that. Okay. So what is this qualitative data, guys? Nominal and ordinal. Nominal kind of data means nothing but nominal kind of data is nothing but we can say that whenever in nominal data, just remember the order doesn't matter, okay? And in ordinal, the order does matter, okay? Order does matter. Now, can anyone can come up with an example and let me know? Anyone can come up with an example. What is this order doesn't matter and order does matter? See, the main thing is, just a moment. Okay, the main thing is order doesn't matter, order does matter. Order doesn't matter means, let's say gender. In gender, does an order matter? No, right? It could be male or it could be female, correct? It could be male or it could be female. But in ordinal, what happens? Here, the order doesn't matter. I mean, order does matter. So the best example we can consider here is education level, okay? Education level, education level. In education level means, so now you people are filling the attendance, right? So what you'll be checking, you'll be going for bachelor's degree, master's. I mean, post-graduation is not there over there. So then in the education, it's an order wise, right? Order does matter over here, okay? Order does matter over here. So did you people understand this? What is this order doesn't matter and order does matter scenario? Qualitative and quantitative data. Quantitative means numerical, qualitative means categorical. Categorical means again means visual data, right? And in quantitative, we'll be having discrete and continuous. In qualitative, we'll be having nominal and ordinal, right? So hopefully this is clear for everyone, right? Yeah, we can say grades also. Hopefully that is clear for everyone, right? Understanding the types of data. So that qualitative and quantitative is very important when you're learning statistics, okay? So Kunda Babu, you're saying that we have only 20 days for AML course. So far, we are covering only the basics. See, Kunda Babu, we are not covering only the basics, okay? Only for Python, we have covered only the basics, okay? For NumPy and Pandas, we have implemented the notebook part also. I don't know if you're present at, yesterday or else day before yesterday. Okay. So, and whatever the statistics part which I'm saying, these are not the basics, okay? These are not the basics. Is that clear? And coming into Janavi, so just try to email Ganesh, okay? Try to email Ganesh regarding your issue. Hopefully it's clear for everyone. Is that clear, Babu and also Janvi? Okay, fine. I'm sharing my screen again. So when I'm asking for a confirmation, guys just drop a reaction, okay? So that I'll be getting to know that you people are understanding, okay? Instead of typing over there all the time, just drop a reaction, okay? I see hand raises. What happened? Kausalya and also Maiti. Fine. So if you are having any doubts on the topic which we have discussed until yesterday, you need to ask at the end of the session, okay? And if you're having any doubts in this session, you need to ask in between the break time or else at the end of the session. Please keep your doubts, and in the meantime, you can update the Q&A, and Tejas will be answering your queries, okay? Do remember that. Okay, fine. So this is about quantitative and qualitative data. Let's dive into the PPT, guys. So again, here we're having statistics and its inference. So what it is saying, statistics is a branch of mathematics involving the collection, analyzing and interpreting the numerical data. And it is also used to control the larger groups of people or things. And here we'll be having the types like descriptive, and inferential statistics. Okay, descriptive and inferential statistics. So what is the descriptive statistics? Describing the properties of the sample and the population data. So we'll get to know about this sample and population data. These are very important. Okay, please do remember what is sample data and what is population data. And coming at inferential statistics, it is saying that using those properties to test hypothesis and draw conclusions. Okay, this testing hypothesis and drawing conclusion is very important. And here the thing is, in statistics, we need to know what kind of data we are dealing with, and mainly statistical implementation is used in machine learning when we are trying to come up with a POC level for any domain. Okay, proof of concept. When you are trying to build a proof of concept for any of the project which we are trying to build. Okay, so let's say I'm having a whole data set. Let's say I'm having a whole data set. In that data set, the thing is, so in that data set, the thing is, I'm having around 1,000 rows. Okay, instead of testing my model on the 1,000 rows and wasting my time, like let's say I have built a model on this 1,000 rows and that build model which is built is not working properly. So I have wasted my time, right? So instead of wasting my time on all those 1,000 rows, what I'll be doing, I'll be considering only few rows. Okay, I'll be considering only few rows, and based on those rows only, I'll be building a POC level. I'll be doing a POC level. I'll be coming up with a POC proof of concept. Then if it is working and if it is giving the solution which I'm expecting, then I'll be implementing the same thing on the whole population, whole data set. That is whole data set. So here we are getting to see the terminologies like sample and population data. Okay, what is the sample and population data set? Now I'll be explaining. So population is nothing but it is an entire data. Okay, population is nothing but the entire data set. Population is nothing but the entire data set. And coming on to sample, the observations drawn from the whole data set. Okay, observation drawn from the whole data set means the rows which you are drawing from the whole entire data set. Okay, like a sample amount of a method called sampling on how we will be selecting these rows. Okay, there is this method called sampling and how to select the rows, and is there any pattern followed when selecting only specific rows? Okay, that we'll be seeing. Okay, so I hope the difference between population and sample is clear, right? Okay, let me just check over here. Okay, webinar, are we discussing only on the... See guys, it's the third day, and in the first 2 days we have discussed about NumPy, Pandas and Python, and also we have implemented the notebook part. Okay, and also we have implemented the notebook part. It's not only theory. Okay, coming into statistics, we need to discuss all the things which are present in the statistics like t-test, f-test, all the test, ANOVA test. Then we'll be going for the implementation part. Okay, and so 20 days is enough. I have answered this. You should have the concepts applied in real world scenarios. Okay, fine. Real world scenarios coming into this statistics. Okay, so now I'll be going in that format only. So try to understand. Initially, what I'm trying to do is I'm trying to explain what exactly that particular terminology is, and then I'm coming up with an example. Okay, if you people have observed or not, initially I'm explaining what the particular terminology is, and then I'm coming with an example. Is my voice audible and clear? Let me just change my Wi-Fi. Okay. I hope my internet is stable now and everyone is able to hear my voice clearly. So I have been going through this. Just a moment. I have been going through this chat Q&A chat. So and I see that. So one of you are saying that this is all about basics of machine learning. These are all the prerequisites of machine learning. Okay. These are all These are all the prerequisites of machine learning, and these are necessary. Okay. If you feel like this part, like in order machine learning. And you need to know about the statistics part also. It's not like this is not necessary. Statistics is important. Okay. So population is nothing but it is the. Let me just share my screen. Population is nothing but the entire data set. Okay, population is nothing but the entire data set. Whatever the data set which you are having, that we will be calling it as a population. Okay, and coming into sample means a number of observations drawn from the data set. Okay, it's a number of observations drawn from the data set. So population is nothing but the entire data set, and sample is nothing but number of observations drawn from the entire data set. So there is a process. So in the sample only there is this process called sampling. Okay, sampling is nothing but considering only fewer data points from the whole data set and coming up with a POC, or else building a going into a statistical part, that is building a POC level concept. Okay. So to build all this or to perform all this, we'll be going for this sampling method. In sampling, we'll be having 4 types. Okay. So the types we'll just dive into the PPT and we'll see that. So this is about the statistics and its inferences, the types of the data which we are having, and here we can see the types of the statistics: descriptive, inferential, and measures of central tendency. Also we will have measures of central tendency means mean, median, and mode. So we need to know where to use mean, where to use mode, and where to use median. Okay, we need to know that, and those things will be coming under the measures of central tendency. Okay, and coming into measures of variability, here we'll be having range, variance, and dispersion. Range, variance, and dispersion. So this is the types of statistics which we'll be having, and under the descriptive statistics only we will be having this qualitative and quantitative data. Okay, and coming into sampling. In sampling, what are the types we are having? Random sampling, stratified sampling, clustered sampling, and we will be having another type called systematic sampling. Okay, and what is the other type? The other type is systematic sampling. Okay, so let me just write that. So sampling, what did I say about sampling? It is like a fixed number of fixed number of observations drawn from the population. Okay, drawn from the whole population. So sample, you can consider that specific part of the data also, we can say, instead of saying that you will be getting confused between sample and sampling, but both means the same. So for that, you can say specific part of the data, So sampling means nothing but fixed number of the observation. Okay, fixed number of observations. And in this sampling, we are having in this sampling, we are having 4 types: simple random, systematic, stratified, clustered. Okay, so these are all the sampling types. Okay, we have what are the types? What are the types of samplings we are having? We are having simple random sampling, systematic sampling, stratified sampling, and clustered sampling. What is this simple random sampling? So simple random sampling is nothing but so picking the samples randomly, okay? Picking the samples or else considering the samples randomly from the entire population, okay? Randomly samples were drawn from entire population is the whole data set, okay? The data set means two-dimensional data frame. That will be calling it as a data set, okay? Where you'll be having rows and columns. So I think my voice is breaking. Just a minute. Is my voice clear now? Is my voice clear now? Is it still not clear? Is it okay? See, for some people, my voice is clear, and for some people, yeah, it's clear, fine. So please also, before that, please confirm, please check with your internet connection also. Okay, fine. So now we are discussing about types of sampling, right? Thank you. So simple random sampling we are having systematic sampling, stratified sampling, and also clustered sampling. So what is this simple random sampling? Simple random sampling is nothing but randomly samples. I mean the samples are drawn randomly from the entire population. Okay, the samples are drawn randomly from the entire population. So randomly samples are drawn from the entire pop in the sense population. Here it is. So coming to systematic, okay. What is this systematic sampling? Systematic sampling means we'll be taking the considering the rows at the regular intervals. So let's say regular intervals in the sense, let's say there is a huge line, and in the huge line, we are considering every alternate person. At every two, we are considering one person. Okay, at every two interval, so we are considering the person. So 1, 2, the second person will be considering. So in a huge line, we'll be considering the every second person in the line. Considering the every second person in the line. So that is what at regular intervals is. Systematic sampling is nothing but regular intervals. Okay, at regular intervals. So the best example is nothing but in a in a market yard or else in a supermarket while you are about to pay your bills, you'll be standing in the queue, right? So there newly a counter is open, so he'll be considering alternatively every second person. So you can consider that as an example. Okay, you can consider that as an example. Systematic means at regular intervals. Okay, and coming into stratified. What is the stratified? I have already written this systematic. Are people able to see, right? Yeah. Right. So stratified. What is the stratified, guys? Stratified means here the things are divided into subgroups. Okay. Okay. So whatever the data which we are having, it will be divided into subgroups, and the subgroups are called as strata. Okay, strata. Those subgroups are called as strata. Okay, and from that subgroups only the samples will be considered. From the subgroups only the data points or else the observations will be considered. Observations or else the data points both means the same. Okay, observation of the data points both means the same. Subgroups which are called as strata. Fine. So coming into the stratified. So random sampling means we just got to know that randomly the samples will be considered from the entire population. Okay, that is fine. So systematic means we got to know about at regular intervals, right? Regular intervals in the sense like every second or else every fifth person, every 10th person. You can take that as an example, okay? And coming into subgroups in the sense, let's say that we are having a data set. Let's say we are having a data set, and in this we are having a column. Let's say that column is the type of what is the type of a house? Just a moment. Okay. So the types of sampling we are discussing. We have discussed about simple random sampling, systematic sampling, and stratified. We are able to discuss about the stratified. And stratified means in stratified what happens is initially the data will be divided into subgroups. Okay. Initially the entire population will be divided into subgroups, and that subgroups division is known as strata. Okay. The subgroups is called as strata. 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 Okay. And then from that subgroups, the observations are drawn. Okay, from these subgroups, the observations are drawn. The observations are drawn. So that means that what does it mean exactly? So let's say I'm having a column. I'm having a column, and the column is type of house. Okay, type of house. So in type of house, what are all the things I can have? I mean, what kind of values I could have in type of house? I could have the type of house could be independent, independent, villa, or else a farmhouse, or else a flat. Correct. So let's say I'm having a whole entire data set which is related to this housing, which is related to housing, and in this I'm having a column named type of house, and for that type of house I'm having this independent, villa, farmhouse, flat as the values. Okay, these are all the values which are present in the type of the house. So now my entire population or else my entire data will be divided into these types. Okay, these are the subgroups here. These are the subgroups here. Based on these subgroups, the entire population is divided, and from these subgroups, the sample observations or else the observations are drawn, or else the data points are drawn from these subgroups. Okay, in stratified, that is what the subgroups is. Okay, that is what the strata is, and that this is how the observation are drawn in the stratified. Is that clear, everyone? Okay, yeah, thank you. So if you feel like, there is a network issue from my end, do let me know immediately, okay? Do let me know immediately. And coming into the other one, what is the other one? Clustered. What is this clustered? In clustered, we will be dividing the data into groups again. But how we will be considering the based on the here again the data is divided into groups. So let's say I'm having around 10 cities. Okay, the best example of this cluster is I'm having around 10 cities. Okay, and in these 10 cities, I want to do a survey. I'm doing a survey and I have considered 10 cities, and in these 10 cities I want to know the survey of this all these 10 cities. So here I just need to visit only one area in one city to get to know about that city. Correct. To get to know about that city, I can just visit one area and I can ask survey the people over there in that particular area, and I can get to know about that city. Correct. So from each city, I'll be picking only one area. Let's say I'm having 10 cities. So from 10 cities, I'll be picking only one. And in the 10 cities, let's say each city is having 5 areas, I mean 5 streets. I'll be picking only one single street over there, and I'll be doing the survey over there. So that is how in clustered also it is the sampling. So in sampling also, in clustered sampling also, initially the data will be divided into groups, and from that each individual group, a few of the data points are drawn. Okay, few of the observations are drawn, and that's how we'll be performing a clustered sampling. So these are all the types of samplings. Okay, these are all the types of samplings. But why exactly we need to know about these samplings? So we'll be having different domain related data, right? So mostly we'll be dealing with medical data, or else any financial data, or else the data which is related to marketing, which is related to HR, and which is related to observing the patterns of any particular sale of a product, or else observing how a drug uh, result is in a pharmaceutical company. We'll be observing how the drug results are. Okay, how the drug results are. So in those scenarios, or else in those situations, mostly we'll be going for the types of sampling methods. Okay, the types of sampling method. Okay, fine. So this is about the types of samplings. Okay, so today just we have discussed about the types of data, structured and unstructured, and under the structured we have discussed about the qualitative data and quantitative data. So quantitative data means numerical, and qualitative is categorical. So types of the data I was saying, that is done, and after that we have seen about the central tendency concept. What are these measures of central tendency? So here there we are having mean, median, and mode. So most of you people know mean means the average, the median is the middlemost value, and coming into mode is nothing but the most frequently repeated value. Correct. So that is about mean, median, and mode. And moving forward, then we have dived into statistics. In statistics, we just, into this population and sample difference, and what are the types of sampling methods. In the population means we got to know that it is an entire data set, right? Coming into sample means fixed number of observations which are drawn. Okay, it's like a specific data points which are being drawn from the entire population. Okay, and so here we have a sampling. What is the sampling again? It's again the same, drawing a fixed number of observations from the entire data set. Okay. So hopefully everyone got about this sampling. So I'll just repeat that once again. Let's say, for example, I'm having a data set and I'm having around 1,000 rows. Instead of building my model on 1,000 rows, I'll be considering only 100 to 200 rows, and I'll be trying to build a model, and I will try to test that. If that is working fine, then I'll try to build my model, and I'll consider all the 100 row values. Okay, but how to consider only those 100 to 200 values? There were few methods for that. There were actually around 7 methods, but we will be discussing only 4. Okay, that is simple random, systematic, stratified, and clustered. And in simple random, it is nothing but randomly the observations are drawn from the entire population. Okay, observations are nothing but again the rows. Okay, observations are nothing but again the rows. So randomly the samples are drawn from the entire population in simple random sampling. And moving on to systematic, in systematic, the samples are drawn at a regular interval. Okay, we need to mention interval or the step. Okay, at what step? Okay, we'll be mentioning that intervals, and at that time period the observations will be drawn. Okay, the observations will be drawn. So what does it mean the observations are being drawn at regular intervals? So let's say there is a huge line. For example, yeah, we have considered this example previously also. Let's say I'm having a supermarket data set, and I'm having the details of each and every person standing in the queue, and what are all the items they're carrying in their basket. Okay, so and now what I need to do is I need to perform systematic sampling over there. Okay, I need to perform systematic sampling, and I need to find what kind of products are being bought mostly by the users. Okay, so at that time I can go for systematic sampling. Here regular interval. So in that huge line, let's say I'm the new cashier over there at the new counter. So I'll be picking at regular intervals, like at every second, or else at every third, or else at every fifth. I'll be picking few customers. I'll be picking few customers, and then I'll be trying to come up with a POC concept, and then finally I'll get a product and I'll be analyzing that. So this is the most product which is got by most of the people. So if you are considering the people line by line, so we'll be missing the other data point. Let's say in that whole entire population is 1,000, right? So if I consider only first 100, maybe I could be missing the better data which is having a very good pattern. Correct. So in order to make sure that we are not being biased, we'll be going for this sampling methods. Okay, we'll be going for these sampling methods. And so I hope systematic and simple random is clear. So coming into stratified, stratified means subgroups. So dividing the data into subgroups is nothing but the strata. So that thing we'll be calling it as strata, and the observations are drawn. Okay, and the observations are drawn from the subgroups. From the subgroups only the data points are drawn. So here we are having this column called type of house. The example was type of house. Let's say I'm having a real estate data set, and the example was type of house. Here the type of the house is independent, villa, farmhouse, and flat. So these are all the values which are present in the column type of house. Okay. So I'll be dividing the data into these groups, in these four groups, and then I'll be picking randomly the observations from all the four groups. Okay. Then I'll be picking the observations from all the four groups. That is about the stratified sampling. Coming into clustered, in clustered we'll be dividing it into groups. Okay. In groups the data will be divided. Let's say I need to do a survey, and I will be dividing that into 10 different cities, and in that 10 different cities I will be picking only one area, and I will get to know about that whole city. So in a similar way, after dividing the things into group, then I'll be considering few random samples. So for this cluster you can consider the car data set. Okay, cars data set. So type of the car, sedan, SUV, and the racing kind of car, or else yeah, sedan SUV you can consider. Let's say I'm having sedan SUV as two groups. Okay, and from these two groups I'll be picking only the random observations or random samples, and I'll try to come up with the POC. Okay, I'll try to come up with a proof of concept, and based on that I'll be providing, I will be proceeding with the entire population. Okay, entire population. Hopefully these two concepts are clear for everyone. Are these two concepts clear for everyone? So once we are done with this, we'll be diving into hypothesis testing. Okay, we'll be diving into hypothesis testing, and what is hypothesis testing exactly? What is null, and what is ambiguity? Sorry. So write that measures of central tendency also. And we will also discuss today, once we're done with this hypothesis testing, we'll discuss about normal distribution. And after that, we'll be discussing this Bayes theorem, central limit theorem. Then, then we'll be going for this IQR method. Okay, there is this IQR. Okay, IQR method. When we are mostly about to dive into data pre-processing, we'll be discussing that IQR method. Okay. Okay. Fine. So let's have a break for 10 minutes. Okay, let's have a break for 10 minutes, and between, if you're having any doubts, do let us know. The attendance link has been shared in the chat, okay? The chat and in the Q&A. Please refer to that attendance link, okay? Have a 10 minutes break and please be back here by 3:40, okay? So hopefully everyone are done with their attendance, guys. So I'll just give another 2 minutes. So please complete, do fill your attendance. Okay. No need to mention use pics over here. Okay. No need not to mention over here. Need not to mention over here. Just you can drop like yes or no. Or else it's totally fine if you're done. Okay. Need not to mention here. Okay. Below what parameter or what value you're getting, if any? Under what option you're getting, if any? Is it separately over there or else is it included under any particular query? So guys, under any you can mention if you are university or if you college, mention it over there. Please mention over there, or else if it is your university or else your qualification is not mentioned or else your learning. In that case, you can mention under if any. If not, just keep it as not applicable. Okay. In A is not applicable. Okay. Yeah, yeah. I had just seen that. I had just seen that. And this Credly account we'll be discussing in the last 10 minutes. Okay. In the last 10 minutes of the session, we'll be discussing what are all the things we need to follow. Okay. And coming into Praveen, even the your query, please try to, we'll be discussing that query. Okay. But the thing is, we'll be discussing that in the last 10 minutes. Okay. In the last 10 minutes, we'll be discussing. Yes, Abhinav, you'll be having these assessments and also you need to do a project over there. Okay. So if next time if you're doing if any, in that place just mention NA not applicable, or else if you're having any other queries, if you want to, if you're like you're asking you change your track and all the scenario, if you want that to be resolved, you can mention it over there. But I suggest you to directly connect with Ganesh through mail. Okay. So just leave that NA, any, mention it as NA. Okay. We'll be proceeding with the remaining things. Okay. Just a moment. Let me just share my screen. Sorry, I was on mute. So I was just saying about what are all the topics which we have discussed. Now we'll be discussing this hypothesis testing. In hypothesis testing, we'll be having null and alternate hypothesis. But initially, what is this hypothesis testing? Hypothesis testing. So what does it say exactly? It says that hypothesis testing is required when a particular statement is passed on a dataset, or else a particular statement is assumed to be true, and we just want to know whatever the data set which we are having. So let's consider an example. You want the things in an example format, right? So let's say consider an example called as pharma domain. Okay, pharma domain. And in pharma domain, the thing is, let's say you are working in a pharma domain and you have developed a drug. You have developed a drug, and for that drug, the assumed statement is the assumed statement. Let's say assumed. Okay, assumed statement is drug is good. Okay, drug is good. Drug is good. And coming into this, what could be the, I mean, this is a assumed statement. And in order to prove that is assumed statement is true, in order to prove this assumed statement is true, we'll be going for hypothesis testing. Okay, we'll be going for hypothesis testing. Hypothesis testing. Okay, so hypothesis testing, what are the things? What is this hypothesis testing? In this hypothesis testing, we'll be having two types. Okay, we'll be having two types: null hypothesis, hypo, and also let me just write it in the notepad. This will let me know if writing the content in the notepad is making you people to understand the things, or else directly explaining you can understand. How it is better, in which way it is better. Guys, in which way do you feel like do you want me to continue? Can I directly explain the things by looking at the PPT, or else do you want me to explain the things through? Okay, only few people are listening to the session, I guess. Only uh, the other people are listening. Proceeding with the keep these images, please. What that we are going to discuss? We are going to discuss about hypothesis testing. Hypothesis and it hypothesis. So, what is this hypothesis testing? We'll be doing hypothesis testing when there is an assumed statement. Okay, assumed statement. So, what is the example that we have taken? We have taken an example related to pharmaceutical domain, right? Pharma domain, and we are discussing, or else we are having a data related to related to drug. Drug is nothing but a medicine. Okay, pharma will be calling it as drug, but it is related to a medicine. Okay, it is related to a medicine. You can consider any paracetamol, citrullin, or else you can consider yeah, COVID vaccine. You can consider, let's consider COVID vaccine. Okay, so hypothesis testing we'll be doing whenever we want to prove our point. Whenever we want to prove our point, we'll be doing this hypothesis testing. But in hypothesis testing, initially we need to assume two statements. We need to have two statements. Okay, so by default, the null hypothesis statement will be always as the assumed statement. It will be always as the assumed statement. Okay, assumed statement. So what is the assumed statement? What is this assumed statement over here? Let me just write over here. Hypo will be always as the assumed statement. In null hypo, it will be always as the assumed statement. Okay, so now what is the assumed statement? Let's say the drug assumed statement is drug will work good, or else drug works good. Okay, or else drug works good. Let's say drug is working good. Just a moment, guys. Guys, is my voice audible and clear? Just let me know in the Q&A, guys. Is my voice audible? What are the yes? Everyone is on. Okay, thank you. So where are we again? We are in. We have considered an example. We are able to understand what is this hypothesis testing exactly, and we are right now in consider an example. The data set is related to a drug. We are considering it as an echo vaccine. So the assumed statement, whatever the assumed statement, it will be null hypothesis. Okay. So here the assumed statement is good. Okay. Drug works good. drug works good is the assumed statement. So in null hypothesis, every time the null hypothesis will be, it will always be the assumed statement. Okay, it will always be as a assumed statement. So what is the assumed statement? What is the null hypothesis here? Hypothesis testing on a drug which is developed. What will be the null hypothesis? What is the statement that we are assuming? So we are assuming the drug works good. So the null hypothesis will also be the drug will be working good. What will be the alternate hypothesis? So the alternate hypothesis will be completely a contradictive statement. Okay, contradictive statement, like completely opposite to the null. So in that case, drug doesn't work. Drug doesn't work, or else drug doesn't work good, or else drug doesn't work, which is a contradictive statement when when compared with the null hypothesis. Correct. Whatever the assumed statement will be, that statement is for null hypothesis, and the alternative contradictive statement, which is completely opposite to the null hypothesis. So this one, based upon this entire data and the thing which we are about to find, that will be depending upon this null hypothesis. Okay. So let's say I'm having a data set and I have developed the COVID vaccine. I've developed the COVID vaccine to make sure that everything happens good. Correct. It's not like an assumption, but based on the previous data. So we'll be doing a sample test, right? Initially, based on that only we'll be coming to a conclusion, right? Based on that sample implementation, then I'm saying that that drug is good. So that is my assumed statement over here. That is my assumed statement, and in null. So if I want to do hypothesis testing and to confirm that it will be working well and good. So in this hypothesis testing, I will be having null and also alternate. Okay, null and alternate. So what is null hypothesis over here? Null hypothesis is nothing but the assumed statement, that is drug will be working good, and alternate will be the drug doesn't work good. So here now we are having two statements. Okay, now we are having two statements. So based on the mean and the standard deviation of the data or the columns which we are considering, based on the, see, data set is related to COVID vaccine drug. So in that we'll be having all the calculation, like what is the concentration of what kind of chemical we are using, what kind of liquid we are using, or else what is the concentration mixed, what is the concentration that needs to be given to a patient, and what kind of reactions are we getting at what concentration, what is the each category. These are all the questions, right? These are all the questions which will be popping up. Correct. So based on those columns and considering the mean standard deviation values, we'll be doing a test called p-value. Okay, p-value test. Okay, p-value test, and this p-value will be having a threshold. Okay, p-value will be having a threshold of 0.05. Okay, threshold of 0.05. So the p-value is less than 0.05, then what we need to do is we need to immediately reject the assumed statement. Okay, so that means reject the null hypothesis. So if p-value is less than 0.05, reject the null hypothesis. That means we need to accept the alternate. Correct. We need to accept the alternate hypothesis. Okay, alternate hypothesis. So based on assumed statement and a contradictive statement, we will be performing the p-value test. Okay, p-value test, and p-value test is performed based on the mean and the standard deviation. Okay, and then the p-value which we are getting is less than 0.05, then we will be immediately rejecting the null hypothesis. Okay, we will be rejecting the null hypothesis. But I mean, that means rejecting the null hypothesis means accepting the alternate hypothesis, right? Okay, that is fine, but the p-value is greater than 0.05, then in that scenario, accept the null accept the null hypo, then reject the alternate. Okay, reject the alternate hypo. So this is the main thing when coming into hypothesis testing. Okay, when coming into hypothesis testing, this is the main thing. So let's consider this domain, and in the domain, whatever the assumed statement that will be under null hypothesis and a contradictory statement we need to pass if you are doing a hypothesis testing. So the contradictory statement is nothing but alternate, which means that which is opposite to assumed statement, opposite to null hypothesis. And then we'll be doing the p-value calculation. The p-value threshold is 0.05. Okay, 0.05. 0.05 means we need to reject the null hypothesis and accept the alternate hypothesis. Hypothesis in the sense these things. Okay. Reject the null means, so if my p-value is less than 0.5, what I need to do? I need to say that, so I should not accept this, right? I should not accept this. In that case, I need to accept this, right? I need to accept this, right? So this is when the value is less than 0.05. Rejecting the null. So value less than 0.5, then reject this, accept the alternate. Okay, reject that, accept the alternate. And if the p-value is greater than 0.05, accept the null, reject the alternate. Okay, then we will be accepting the null hypothesis and rejecting the alternate hypothesis. Correct. Okay, so this is about the p-value concept. Okay, p-value concept is very important in hypothesis testing. Okay, in hypothesis testing, the p-value concept is very important. So, how many of you understood this hypothesis testing? How many of you understood this hypothesis testing? I hope everything is clear, right? Anyone, any more doubts? Okay, thank you. So, Chindu, you're saying that p-value, right? P-value is nothing but the probability value. Okay, the probability value. Probability of value of, if you're considering the sample over there for that sample observations or else for the entire population. If you're considering entire. Is that clear, Chindu? So, Shehnaz, you're saying about you didn't understand about hypothesis testing, you're saying? Yeah, okay. So I'll just refer to the, please keep questions to yourself, okay? Shehnaz, Chindu, Janvi, please keep questions to yourself. In the next 10 minutes, we'll be doing the recap, okay? We'll be doing the recap, okay? Please. In the next 10 minutes, again, I'll be asking whatever the doubts you're having. Then please do update all these things in the Q&A so that I'll be answering, okay? And yeah, the people who have raised their hands, Tarun, Sudharani, and also Rizwan. If you're having any doubts, please update in the Q&A, okay? Tejas, I will be helping you out, okay? Also, Lakshmi, if you're having any doubt, please update in Q&A. Okay, I'm sharing my screen again. So we'll be completing that PPT part, okay? The hypothesis testing. So it is nothing but, so this is a definition you can consider, okay, for hypothesis testing. So what it is saying, use it to determine whether to reject or fail to reject the null hypothesis, okay? Reject or fail to reject the null hypothesis. Fine. So this is about the hypothesis testing. Now we'll be diving into the Bayes theorem. Okay, Bayes theorem. So what is this prior and the posterior probabilities practical applications? We'll just go once with the definition. What it is saying? It is saying that Bayes theorem calculates the probability of an event based on the prior knowledge, and it uses the prior probabilities and new evidence to determine the posterior probability. Correct. So what does it exactly mean? What does that exactly mean? It means that so calculating the probability of an event occurring. Okay, we are calculating the probability of an event occurring. Let's say I will be calculating the probability of it will be raining tomorrow or not, and how I will be calculating based on the how I will be calculating based on the previous data. Okay, based on the previous data. Previous data is nothing but the prior observations. Prior observations, I can say. Prior observations, or I can say that the previous observations. If you want it clearly, I can say previous observations also. Okay. So depending on the previous observations or else the prior probability knowledge, I will be calculating the probability of an event. Okay, I will be calculating the probability of an event if it occurs or not, and then I will be saying the posterior probability. Then I will be saying the posterior probabilities. Posterior probabilities is again that means that what could be happening. Okay, what could be happening. Okay, fine. So now I'll just open my notepad and I will just write this Bayes theorem formula, and we'll be considering an example, and then we'll be discussing how it will be happening over there. Okay, and coming into practical applications. So what is this practical application means? Widely used in medical diagnostics, spam filtering, machine learning. So in this medical diagnostics, spam filtering and machine learning, what are all the prior probabilities will be? The prior probabilities will be the diagnosis reports of all the patients related to any medical field, or is related to any particular domain in medical. So all the prior reports, prior diagnostic reports, that means the previous observations. And spam filtering means all the mails which we are considering as spam previously, and all the machine learning algorithms, or else what kind of problems can be solved by the machine learning algorithms which have already been done. Okay, which have already been done, or which have already are in the process. Okay, which were already in the process. So based on all the previous observations, we will be, or else based on all the previous observations, we will be calculating this calculating the possibility of that event happening. Okay, calculating the probability of an event happening. Let me just write. So Bayes theorem. So what exactly it is? We'll be having so based on the previous or else prior observations or else data. Based on the previous or prior observations or else data, we'll calculate the event happening or occurring. Event happening or occurring. Event happening or occurring. That means that we'll be calculating the probability of posterior probabilities. Posterior probabilities. You can consider it as post probabilities. Okay, like the upcoming what could be the answer for this? So the best example you can say that based on the rain data, based on the based on the weather data of the whole week, I want to calculate that will it rain tomorrow or not. Okay, I want to calculate like will it rain tomorrow or else will it rain in the next few days. in the next upcoming few days. I want to calculate that. So even if you see here, you say that Bayes theorem calculates the probability of an event based on the prior knowledge, and it uses the prior probabilities and a new evidence to determine the posterior probabilities. Okay, so that is what exactly the Bayes theorem is. Okay, that is what exactly the Bayes theorem is, and in this Bayes theorem we will be having a formula, and that formula is, the formula will be we'll be having two values. Okay, we'll be having two values. We'll be having P of A and also P of B. So it is like probability of A and probability of B. Okay, probability of A and probability of B. Okay. So now the formula goes like, as probability of A of B, which is equal to probability of P of A into T of A to the whole, it will be P of P. But what exactly what exactly is this P of A and P of B? What exactly is P of A and P of B? It is probability of A and probability of B. Okay, probability of A and probability of B. So let's say in a weather data set we are having two columns. Okay, in a weather data set we are having two columns, and based on the two columns we will be predicting will it rain tomorrow or not. Okay, based on those two columns we'll be predicting that it will rain tomorrow or not. So we'll be having probability of A, which is happening, which could be happening, like the P of A is probability of A occurring, prob of A occurring, and B will be prob of B occurring. Okay, B will be prob of B occurring. Okay. So now, what is this P of A by B? What is this P of A by B? So P of A by B is nothing but, so P of A by B. P of A by B is nothing but the probability of A given B. Okay, the prob of A given B. So here we'll be considering the probability of A by B. We'll be calculating the probability of A based on B. Okay, whatever the B column value or else the B value we are considering will be, let's say we are having two data points. Okay, so A and B. So we'll be calculating the given B and the probability of A. Okay, so A by B is the probability of A given B. The B is given and we will be calculating the probability of A. Given B, calculating the probability of A. Okay. So, and the one more thing was, so P of A is clear, P of B is clear, and P of P of B is also clear. Now P of B by A. So P of B by A, where is this? Here it is. So P of A by B means we just got to know that it is A by B, right? So A by B, probability of A given B, right? So what will be B by A? B by A will be, something similar but quite opposite. That is the prob of B given A. The probability of B considering the A value. So let's say I'm having two values. Okay, let's say I'm having two values so weather data set we are considering, right? So weather will be calculating based on the humidity, based on the precipitation, based on the previous year data. So let's say precipitation and the humidity we are considering over here. So those are the two columns. In the two columns we are having two values. Okay, one will be going for A and one will be going for B. So let's say A is presp and B is humidity. Okay, A is presp and B is humidity. So for those two, A and B, so P of A is nothing but the probability of A we'll be calculating, and B is nothing but the probability of B. So P of A by B is nothing but probability of whatever the values which we are having in A and B, and then followed by the probability of A given B, then the probability of B given A. So this is a, formula. Okay. This is the formula over here for the probability, okay? So hopefully the probability formula is clear for everyone. Probability in simple it is nothing but calculating the things, okay? Or else it's like finding out or else calculating the events occurring, calculating the event occurrence. Like based on the previous observations, the data will be calculated and the events which are happening, okay? So mostly that is about probability. So is it clear? Is it clear, guys? The probability thing, is it clear? Okay. Thank you, guys. Thank you. Thanks for the confirmation. Okay, fine. In this probability, what we'll be doing is here there is this another thing which we'll be considering, that is we will be having likelihood, marginality, and also we'll be having prior probability. So whatever this P of A which we have written, okay, let me just share the screen. Okay, I'm sharing my screen, okay. So in this base theorem, the formula is the probability of A and probability of B, probability of A given B. So what is this P by A? Or I mean P A by B. P A by B means like or is P B by A. We'll just consider P B by A. Okay. P B by A is nothing but the probability of B being true given A is true. Okay. Probability of B being true given A is true. So this is what it is exactly. So here, what it is, probability of A being true, given B is true, okay? Given B is true. So this is what about the probabilities, okay? This is what about the probabilities. And this is the Bayes theorem formula, okay, which is very important. So it's nothing but based on the prior probabilities, we will be calculating if an event will be occurring or not. And based on that, whatever the output we are getting, that will be considering it as a posterior probabilities. Okay. So is the Bayes theorem clear? I think hopefully it's clear for everyone. So now, whatever the doubts everyone is having, please drop it in the Q&A chat. Okay. Whatever the doubts, if you feel like still you want to get a clarification, please drop it in the Q&A chat. Okay. Venkata Sai Gopi, the class timings are 2:30 to 4:30. Okay. 2:30 to 4:30 are the class timings. Yeah, Purna Pujita, you're saying that is it compulsory to do the digital application fundamentals? So please do register it and to complete that. Okay, it's not like compulsory, but it is for better you. Okay, it is better for yourself. So please do register in that. And okay, so what are the other things I missed? Data frame, recap the sampling concept. You said you will explain what is that hypothesis testing, and hypothesis testing, data frame, sampling concept, and also Chandra is asking about where do we use this hypothesis and Bayes theorem, and also Okay, Sai Aditya, I'll be explaining that. Okay, attendance form is telling you haven't responded. Jeshwant, please check the form link. Okay, please check the form link. Everyone has filled the form. If for you, if it is saying that you have been already responded, so please make sure that you are clicking on the correct link. And coming to Aditya, I'll be explaining that. And moving into what was the question? Quick recaps of today's class. So, Aisha, so you're saying that quick recap of today's class, and also Shehnaz and Janvi. So please do listen, guys. Also, Chendu, you too. Whatever the things I am saying, please do listen so that you'll be getting way to use this hypothesis testing exactly. Okay. So I will be doing a quick recap in like two minutes. Okay. So initially we had discussed about the structured and the unstructured data, and in the structured data, unstructured data, in structured we will be having this quantitative and qualitative data. Quantitative data means it's a numerical data, okay, and the qualitative data means categorical data. Categorical data means it's a textual data, okay. And in quantitative data, we will be having discrete and continuous. Discrete is nothing but number of cars in a parking lot. So we can count them. We can count them, right? We can count them. Number of cars in a parking lot means we can count those values. Correct. Or else number of students in the class. We can count them. So that kind of column will be discrete. Okay. That kind of column will be discrete. So let's say I'm having a data set related to a car parking lot, or else the city center, what are the shopping malls I'm having, uh, I am calculating their revenue. In that, one of the column is parking lot. Okay, so that column will be discrete in that case. What kind of data it is means, I can say it is a quantitative data and it belongs to discrete group. Okay, so similarly we will be having continuous type of data. Continuous means we'll be having a certain range. And what does that certain range mean? It will be having the minimum and the maximum value, and between that the values will be varying. Okay, we'll be having a minimum and the maximum value, and between that the values will be varying. So that means that let's say considering the height of the all the children which are present in one single section. Okay, so that there will be having, there will be few kids who are very tall, and there will be few kids who are very short, right? So certain range, between a range I will be getting. And similarly, qualitative data means categorical text, nominal and ordinal. Nominal means order doesn't matter. It could be male or female, and ordinal means the order does matter. So in that case, it will be education level. Okay, it will be education level. So this is about that structured and unstructured. So coming into population, so I'm having an entire data set. So someone was asking about the data frame. Okay, so data frame means it's a data frame is a two-dimensional array. Okay, data frame is two-dimensional array. Two-dimensional array means it will be having rows and also columns. Okay, rows and also columns will be having in a data set. Let's say we all know Excel, right? In Excel we will be storing the uh, values as per that name, right? So let's say I'm having a column type of a car, so I'll be saving that particular column. Let's say I'm having another column, ice cream type. I will be saving that also in the Excel sheet, right? So there, whatever the 1, 2, 3, 4, 5, 6, those numbers you're seeing on the left side, though they will be the rows, and whatever on the top you're seeing, whatever on the top alphabets you're seeing, that will be the columns. Okay, that will be the columns. Okay, that will be the column. So, and the combination of rows and columns will be a data frame or a data set. Okay, so data is nothing but a two dimensional array. Two dimension is nothing but rows and columns. Okay, so that whole entire data set we'll be calling it as a population, and sample is nothing but considering only fixed number of observations. Okay, sample or sampling is nothing but consider only few specific data from the whole entire dataset. Whole entire dataset considering only few values. And the whole entire dataset considering only few values is nothing but sample, and that sample we will be having a sampling process. And sampling we are having four types. That is simple random sampling, systematic sampling, stratified sampling, and clustered sampling. So what is this simple random sampling? Simple random sampling is nothing but again randomly the samples are drawn from the entire population. Okay, randomly samples are drawn from entire population. So let's say I'm having a data set of around 1,000 rows, and from these 1,000 rows I'll be randomly considering only 200 values, and these 200 values will be randomly picked. Okay, these 200 values will be randomly picked. It will not consider the first 200 or else the last 200. It will consider, it will randomly pick the 200 observations from the whole 1000 observations. Okay, from the whole entire data set, it will randomly pick these 200. Okay, so that type of drawing samples from a entire data set or population is known as random sampling. And systematic sampling, in systematic sampling we will be considering the we'll be picking the things, or else we'll be drawing the observations at regular intervals. Okay, at regular intervals. In that case, we can say in a row we are having around, I mean in a column, let's say in a column, I'm having how many values? I'm having 100 values. Okay, I'm having 100 values in a column. I want to consider every second value. Okay, every second value I want to consider. So what are all the values I will be getting? The values which is present in the second row, fourth row, sixth row, eighth row, 10th row, 12th row. Those values I will be getting. Okay, for every two steps, for every two steps I will be getting. So that is known as the regular intervals. Okay, and coming into stratified, we will be having subgroups which can also be called as strata. And in this strata, the observations are drawn from the subgroups. Okay, the observations are drawn from the subgroup. I'm having a data set related to housing, and in that one of the column is type of the house, independent, villa, farmhouse, and flat. These four, and from these four subgroups, these four are subgroups now. From these four subgroups, again randomly, the data points will be considered. Why we need to consider picking this data randomly from the data set? Because in order to make sure that whatever the row patterns which we are having, whatever the row value patterns which we are having, the model is learning from those patterns. The model is learning from those patterns. Okay. Like we'll be getting to see each and every data type. Okay. Each and every data type we'll be getting to see. If we consider only first 200 values, maybe the first 200 values are good. The other remaining value results are completely very bad. So in order to make sure we are not being biased, we'll be picking randomly. Okay. Clustered means in clustered we will be dividing it into groups, and then we will be considering the values from the groups. Okay, let's say I need to do a survey. I need to do a survey, and I'm having around 10 cities, and from the 10 cities, for each 10 cities I'm having multiple areas. Okay, so in these 10 cities I'll be picking each city. In each city I'll be picking one area, and I'll be doing the survey. Okay, so I'm dividing that cities into areas, and from that areas I'm doing only one single area. Okay, I'm doing that one single, picking that one single area. So that is what the groups in clustered format. Okay, dividing the whole entire data set into cities, and from the cities picking only one area related kind of observations. Okay, and then moving forward, we have discussed about central tendency. And the central tendency will be having this mean, median, and mode. So mean, median, mode, you people are aware of it. Mean is nothing but the average, and median is nothing but the middlemost value, and mode is nothing but the frequently repeated value. And then we have dived into hypothesis testing. So null hypothesis will be the assumed statement, and the hypothesis testing will be having null and alternate. Alternate will be completely opposite to null hypothesis. Correct. So we'll be doing the probability calculation, probability value calculation based on the mean and the standard deviation. Based on the mean and the standard deviation, we'll be doing the p-value. And in the for p-value, the threshold value is 0.05. And if that p probability value of the whatever the data set, or else whatever the samples which we are considered, for that probability value is less than 0.05, then we need to reject the null hypothesis and accept the alternate. And if it is greater than, accept the null and reject the alternate. Okay. Coming into Bayes theorem, based on the previous or the prior observations, we will be calculating the event occurring or not. Okay. So this is in short about what are all the things which we have discussed. So anyone, any more doubts? So Credly account, guys, Credly account. So you need to do getting started with artificial intelligence. You need to refer to that course only. Don't refer to any other course. In Telegram, initially the wrong link has been shared. Okay. So don't consider that link. Now consider the updated link which has been updated after 10 o'clock today. Okay. And yeah, today definitely I'll be sharing that January. I was actually working on different things parallelly, so that is the reason I was not finding time to share these IP binary files. Okay, I'll be share those files January, and along with those files, Tomorrow we'll be discussing this central limit theorem, and also the data pre-processing will be starting. Okay, and need not to worry. Okay, if people are considering that we are just having only 20 days, how we'll be completing those algorithms? Need not to worry. We'll be completing all the things. Okay, and don't feel that these are all the theoretical part. These things are necessary to understand. Okay. Yeah, Abdul, the IBM course is it is getting started with artificial intelligence. Okay, that is the course. And if you enroll in that, if you scroll down, you'll be finding three course links. Okay, three different courses you will find over there. You need to do those, complete those three courses, and after completing those three courses, you'll be getting a certification, and that certification you'll be able to find in Credly. Okay, Credly is just for certification purpose, nothing to do with Credly. For now, complete those three courses. Okay. So fine, I'll just keep a poll and I will end. So just let me know, guys, in the Q&A chat, did you understand today's session or not? Yeah, please let me know through the poll, and once that is done, Sheikh, you can leave the class. Okay, Suraj, you can leave the class. Please let me know the things through the poll. So once that is done, you people may leave the session. Okay. Thank you for attending the session. So please don't forget to attend the session tomorrow. Okay. And one more thing, guys. So please don't update the screenshots of your attendance. Okay. If you are having any issue while filling that link, or else you're not able to access the attendance link, then only let us know. Okay? Don't update that screenshot in the group. Okay, in the chat. Okay, because whatever the other people are keeping, whatever the doubts they were keeping, I'm missing those doubts. Okay. Okay, I think everyone is good, right? I can end the session, right? So if anyone is left over to do the poll, please complete the poll, and I'll be ending the session in 2 minutes. Okay. Okay, Suresh, that is fine. Okay. I was actually creating a poll. Okay, so the people who are done with the poll, you may leave. And yeah, others may also leave once you're done with the poll. Okay, and I'm ending the session now. Okay, in the next 1 minute, I will end the session. Okay, guys, I'm ending the session. Hopefully, everyone done with the poll, I guess. Thank you. Yes. Okay, thank you, guys. Thank you. You may leave the session, everyone. You may leave the session. Thank you. Thank you, everyone. So, Anant Lakshmi, you're saying that what should we do if you have completed the previous IVM course? What previous IVM course? You're talking about the chatbot or else getting started with artificial intelligence? See, that is what I am asking Manikanta. So do let me know. Do let me know, Shravanti and Manikanta. Chatbot, please ignore. Okay, chatbot, don't consider that. And also do remember that whatever the mail that you have registered with this session, use that same mail ID and register in this getting started with AI course. Okay. If it is completed previously, if that getting started with AI is completed previously, then what you can do is you can directly mail the Credly certification link. You'll be getting certification in Credly, right? You can copy that Credly certification link and you can mail to Ganesh. Okay. Okay, fine. I'm ending the session now. Hope it's clear. And whatever the doubts others are having, you may ask me tomorrow. Okay. Thank you. Thanks everyone. Have a good day.